So when 4-bit microprocessor was there, so that time our operand which we are using is all or must be in 4-bit. So the results, if you're going to analyze some arithmetic operation, in that time you not more than 4-bit data you're not able to analyze and not able to do some work. Okay, now after that 8-bit microprocessor came into the market. So 8-bit microprocessor means now the data which is the 8-bit, in that time you can able to operate this type of data. That means you can analyze it, you can do some work on it, anything you can do. So 8-bit data you can save also. Okay, na? So this is come into the picture. After that 16-bit, 32-bit and 64-bit. So now we are using 64-bit microprocessor, but sometimes we also use 32-bit also. Many old microprocessors are still in the market which are 32-bit, but mostly we are using core 7, core 5, core 3, and all are 64-bit microprocessors are there. That means the data bit is 64-bit. That at a time you can able to analyze 64-bit data. Okay, now so this is the, you can say, the evolution of Intel microprocessor. I am now talking about only for Intel. I am not talking about the other microprocessor. I am not talking about the Apple processor. I am not talking about the AMD processor. In this whole course, we only discuss about the Intel microprocessor. So this is the evolution of Intel microprocessor. First came into the market 4-bit microprocessor, after that 8-bit, after that 16-bit, 32, and now 64. Maybe the other advancement also in the pipeline, we don't know. Another version may come in the next year or the anytime. Okay, na? So this is the thing. So see that in 2003 single core, in this single core microprocessor 1.7 million transistor was used and 130 nanometer process is there. Now first dual core microprocessor was there, first duet core, first 6 core, 2013 6 core, 12 threads, to 22 nanometer process, like that. So when you are going to develop any microprocessor, you have to suppose when you increase the data bus, when you increase the data bus, when you increase the address bus, when you are going to increase the microprocessor capability, in that time you should increase the electronics which is inside into this microprocessor. So how much electronics I have to use, or if any law is there, how much transistor I have to use, or how much transistor is suitable for development of particular circuit. Some rules are there, and this rule is called Moore's law. So what is the Moore's law state? That nothing. Hello, please switch off your microphone. So in the Moore's law state that per year, after 10 years, how many transistors are needed if you want to develop one particular device. If I want to develop the in one particular device, electronics device, suppose in 2021, so if I want to develop this device in 2031, during this 10 years, how much electronics I have to introduce into this device, it is stated by Moore's law. In the Moore's law, if you see that in this graph, it is x-axis, it is the year of introduction, and y-axis transistor number per chip. That means per IC, how much transistor I have to increase if I want to develop one device continuously every year. This thing or this phenomena stated by Moore's law. So this is the one simple law is there, not a technical thing. It is a one type of assumption. That means today in the microprocessor we are using suppose this many of transistor. After 10 years, if we want to use the device, how much transistor will needed? Because every time the extra feature we needed in our electronics device. You in the 2004, suppose in that time when I was in my BTech college, in that time we can't imagine that our cell phone can take photos, our cell phone can take with the help of cell phone we can access the internet. With the help of cell phone I can access my social media site. With the help of our cell phone I can read PDFs. I not able to think in that time 2004 when I was just joined BTech in one college. But now in my with the help of my smartphone I can do everything. I can take photos, I can read PDFs, I can access my social media site, anything. How it is possible? Size increased my device? No, not so much increased the size. But technology developed so much. And what happened? The components which was much more, which was there in my previous cell phone and now this smartphone. In 2004, the cell phone which I used, if you compare to the components used in that phone, if you compare it with today's my smartphone, I think 1,000 times more components used in my smartphone. For this reason, with the help of the smartphone, I can do any work. I can do any work. But in that time, mobile phone not able to provide you so much facilities. Some we can do some SMS. Some SMS service was there and calling. That's all. Some phone provides some music also. MP3 player was there, but the quality of music was also very bad. That's all. But now we can do anything with your smartphone. Okay na? So why it is possible? Because of possible, every year we develop this device continuously. We develop this microprocessor. We developed the electronics behind the which is behind this microprocessor. Every year we develop. For this reason, transistor per chip in y-axis it is there. So if you see that in 1970, when the first microprocessor was developed, 4004, in that time transistor was just 2000 transistor used in that microprocessor. So we can able to just operate 4-bit data with the help of this transistor only, 4004. So in the 80s, if you see in the 80s, in this 80s, the transistor increased, the number of transistor increased. It is now 10 to the power 4, that means 10,000. After that, next year 1990, not next year, that means the after 10 year. So if you see that it is 10 to the power 5. So after that, in 2000, it will be 10 to the power 6, like that. So like that, every year the I have to multiple 110 with with my number. The number is number of transistors I need to use in my IC. That means if today to develop any electronics device, if I need 10 transistor, after 10 years I have to use 100 transistor. That means 10 times I have to multiply this number. This is a general phenomena of electronics device development. This is a assumption. If today if we want to develop, if you fabricate one electronics device with the help of 10 components, if you after 10 years after, you have to use 100 components, and again after 10 years you have to use 1000 components. You have to use, otherwise your device will not be called developed device, or not be called smart device. So it is starting with 1000. Now in 2020, 10 to the power 9. Now you see that. Now you are using the microprocessor in your laptop 10 to the power 9 transistors needed per chip, not a total. It is not a total chip used in your laptop, just one chip. In this one chip, 10 to the power 9 transistors are there, just in one chip. So if you able to see in your inside your laptop, I think many chips, many IC, many chips are there. I think more than 100 IC chips must be there. So now imagine how many transistors is needed for develop this device. Same thing happen in your smartphone also. For this reason, we can do many works with the help of today's smartphone. Many work we can able to do, but 15 years before, or 16 years before, this type of facility not be provided by any mobile phone. So this is the thing. This is the way of development, develop any IC. So if you see that in 1950, silicon transistor was introduced, one transistor. 1960, we can able to fabricate one gate with the help of 16 transistor. After that, first 8-bit microprocessor we use with the help of 4500 transistor. In 1980s, 32-bit transistor we fabricated with the help of 275,000 transistors. Now we have developed 32-bit microprocessor in 1990s with the help of, I think, 31 lakhs. After that, it will go into the crore. Now the millions are there. So this is the development. This is the way of development of any electronic device, not the microprocessor, anything. But you not be able to use much more spaces. Your spaces must be very less. If you use the space, that means what will happen? Your transistor size must be small. Every year you have to smaller to smaller. Okay, na? So this is the thing. So this is the basic processor architecture. So now I am going into the technical part. First time I am enter in the technical part. So building blocks of processor systems. In this processor, actually 4 control components are there, and in this processor system, the 4 major blocks, not components, major blocks are there. So one is input output, one is the memory, and data path, and control. Simple. This is the most simplest processor design. Memory must be there, which I told you. Otherwise, it is not be called as a processor. Memory must be there. Input output port must be there, because I have to insert, I have to give some instruction to the microprocessor through this input, and also I have to take my result from output. So input output must be there. Data path, that means the supply of data must be there, and control, it is very important. The control is very important. Suppose some data is coming from input. I can save this data into the memory. Also, I take some data from the memory, and through this channel, I can send in the output. Simple, like your pen drive. Suppose in your laptop, you connect your pen drive. Your pen drive, suppose this is your pen drive. Suppose this is your pen drive. In this pen drive, suppose some data is there. Data, suppose data 1, data 2. Suppose 2 data are there. Maybe some movie, maybe some PDF, maybe any document. I am not going inside this. suppose any video song, audio song, anything is there. So suppose you want to insert the data in memory 1. How it's possible? When you just going to this insert the pen drive into your input output device, that means your jack, in that time one control signal will generate. What you want to with this data? This control signal tell that, okay, I have to take this data from pen drive to memory. So through this input output, this suppose this data 1, I am assuming data 1 will come there. After that, it will, through this path, it will go into this memory. Same thing will happen. Suppose previously in this memory, suppose data 3 already saved. I want to send this data 3 in my pen drive. I want to save there. How can I do? Same thing, one control signal will generate there, and it will tell that the data I have to transfer this data 3 into this pen drive. So what will happen? That the data 3 will come into this through this data path, it will come into this path. After that, through this input output, it will go into the pen drive. After that, it will save it there. Now data 1 is not data 1 I already cut paste, so data 1 will be not there. Data 2, data 3 will be there. So this is the very roughly I can say this is the working principle of any processor, and this type of processor is called CPU. CPU, Central Processing Unit. In every smart device, in every laptops, every desktop, every smartphone, this device must be there. Not be so much simple, because now we are using very hi-fi devices, but this is a general architecture. This is the general architecture. Okay, so understand, students? Students, are you understanding? If any question you can ask me. Students, hello, are you understanding? Hello students, please respond. Hemlata, Ganesh, Hari Kumar, Balaji, Naveen, Bhargavi. Please, anyone response? All of you are sleeping or not, I don't know.
Yes, sir.
Okay na, Bhargavi?
Yes, sir.
Okay. So this is the thing. So in the processor system architecture, there are some blocks, or you can say some components which must be we have to introduce. The first of all, CPU, Central Processing Unit. Under this CPU, ALU is there, arithmetic logic unit, control logic will be there, register will be there. Next, the memory. Memory may be a ROM, maybe a RAM, any memory we have to use, but we have to use the memory. And input output interfaces. Input output interfaces means the devices, the components which is helping you to communicate with outer world. Can you give me one example of input output interfaces? Anyone? Can you give me one example of input output interfaces components? Any example? In fact, now you are also using this type of component. Yes? Tell me. Don't worry. If it is wrong, don't worry. Huh? What? Please repeat again.
Mail, sir. Receiving and sending.
What? Still I not understand. Mail. Wasim. Wasim. In the chat box you can reply. Your sound is not audible for me. I am not understand. So you can chat box. You can reply. Okay. Any other? Bhargavi, Ganesh, Balaji. Can you tell me one component of input output interfaces component? Can you give me one example?
Sir, for the computer, there is a keyboard for input.
Yes, very good. For computer, keyboard you are using. This is one input device. Mouse you are using. It is one input device. An output device? Bhargavi?
Monitors.
Yes, very good. Monitor. Speaker. So this is the
Microphone is also interface.
yes. Microphone is also the input device. Yes. So this is the thing. So typical processor consists of CPU, memory. Memory, you know that ROM, RAM, every computer, every laptop, smartphone, it is there, and input output interfaces component like that the mouse, keyboard, monitor, microphone, speaker, this is all. Okay, so these three items is must be there. Three blocks or three components must be there in your in your processor system. Must be there. Otherwise, your processor, it is not called a processor. Okay, so now I am coming to the next topic, interconnection between these units. So if I want to interconnect the CPU with memory, or memory with input output, or input output with CPU, anything, how can I interconnect? Suppose CPU is there, memory is there. Okay, CPU is there, memory is there. So if I want to interconnect if the memory and CPU, if I want to communicate between CPU and memory, what should I do? What is the main thing we should do? Some communication channel I have to establish. I have to establish some communication channel. So this type of channels, yesterday I also told you the same thing, is called address bus, data bus, and control bus. Yesterday I told you address bus holds the address of memory, addresses. Data bus holds data, and control bus holds some signals which give the instruction to the microprocessor. What work microprocessor should do now? So 3 buses, it is nothing but a communication channel, nothing but a communication channel. So 3 buses will separate 3 buses, it provide 3 types of operation. How these buses will work? Suppose this is my CPU. This is my memory. Suppose this is my input and output, and this is my control signal, control. Okay, so suppose I want to access some data from memory. This is memory means some and data are there. Suppose 11001100. This data I want to access, or I want to copy into the output. Okay, so how can I do? How can I do? Yesterday I already given one example in the yesterday class. What I told that suppose if any students want to meet me personally from your class, from the any class, what he or she will do? First of all, he or she should know that where I am staying now. That means he or she first of all know that my address. So now what is my address? Even any student, suppose anyone, suppose Balaji want to meet me. So first of all, Balaji should call me, sir, I want to meet you. Where are you, sir? In that time, now I am in your department. I am in EEE department. I am in the office. So I will tell, okay, you come, Balaji. I am in the department. Balaji will first come into the college. After that, he will come into the EEE department and he will meet me. I am the data, suppose. So before access me, Balaji should know my address. My address is EEE department of the college. So when I want to access this memory, suppose this memory, when I am going to access it, I know the address of this memory first. So every memory holds the address. Suppose this memory address may be 00110011. So first of all, one control signal will generate. Some control signal will generate there. It will tell microprocessor the user want to access this memory. Please find out first or what is the address of this particular memory. So after that, what will happen? This control signal will activate the address bus there. Control signal will activate the address bus. Through this address bus, suppose this is the address bus, the address of the memory come into the CPU. After that, CPU understand, okay, this is the address of this the memory. After that, another time control signal will generate another signal. Okay, the address bus already I found. Now I need the in this address this corresponding data. After that, I can able to access the data, and through this data bus, the data will come into the CPU. Now, what should we do? This data will go into the output device. So this so many steps actually happen, but it will take less than 1 second, I think. Less than 1 second. This is the uniqueness of this thing. But when you copy paste anything, copy paste the data, when you send some data to the your pen drive, when you take some data in your pen drive, so many things happen inside this microprocessor system, inside your laptop, but it's happened so much fast. We're not able to imagine how much fast is happening. So this is the full process of the working principle of microprocessor system. So other some components are there, which I already told you, bus and CPU. Okay, so, students, one thing you have to should do. I am not able to give you the notes now. So this PPT I am not able to share because the Moodle is not activated still now. So you just draw this block diagram, and also you have to draw now this write-ups, processor system architecture. So I am giving you 5 minutes time to draw this building blocks of processor system and processor system architecture. These two things you just noted down in your copy. So I am giving you 5 minutes time. So after 5 minutes I will be back. Okay, okay, students. Okay, students. Hello. Okay, na? All students.
Okay, sir.
So I am giving you 5 minutes time. You draw this block diagram and you write this small write-ups. So I am coming within 5 minutes. Okay.
Ya bola. Good.